Okay, all right. So I see most students have already joined, and I hope my voice is clear and my screen is completely visible. Can someone confirm me?
Yes, yes, your voice is audible.
Okay, thank you, Shailesh. Okay, so before starting today's session, I would just like to announce that this session is uh, freely sponsored by Elite Techno Groups, and it's in association with the AD Patel Institute of Technology. So I heartily welcome all the students from AD Patel Institute of Technology, as well as the faculty member of the college if they have joined. So Professor Samarth Shelat, he's a training and placement coordinator of Automobile Engineering Department, and Dr. Sanjay Patel, he is the head of Automobile Engineering Department. So if these faculties are there. Have joined. So I would like to hear some words from you and encourage the students for to attend this kind of session. Okay, I guess these faculties haven't joined yet. So no worries. We will continue with our session, and if they join, we'll have some words from them. All right. So I hope you guys are excited to know more about this topic. What is the fuel cell technology and how it would be used in electric vehicles, and what are the current trends going on globally in this technology and specifically in our country, India. So let's begin with the today's topic. And the first thing we'll talk about is what exactly we will be getting in today's session. What all things we will cover in this entire 1 hour of session. So before going through all these things, technically, I would like to let you guys know that no, if you have any kind of doubt or query or point of discussion, you know better about that particular topic. So you are completely free to unmute yourself and ask your doubts and take a part in a discussion. And in the end, we will have a detailed discussion on whatever we talked about in the session. So I would really appreciate you guys unmuting yourself and asking the doubts and questions when still when I'm explaining the things. Okay. So don't hesitate and don't shy. All right, but just don't create any kind of disturbance between the session without unmuting yourself or without any reason. I see someone's mic is turned on. Can you please unmute? Sorry, can you please mute yourself? Okay. Just when you have doubt, at that time only you unmute yourself, ask your doubt, and after that keep your mic on mute. Okay, so yeah, without taking not without taking much time, just get started with today's session. So firstly, we'll talk about what is the fuel cell and the definition of it, what is the concept of fuel cell, and after that, we'll talk about what are the different types of fuel cells invented yet, and what could be the application of them, how they exactly operate, and what is the working of it, what mechanism it follows, how does it generate the electricity, what fuels does it use. So those things we'll look at. And after that, we'll find out why only hydrogen fuel cell can be used for electric vehicle application and not some other kind of fuel cells are being used. And after that, we'll see how does the hydrogen fuel cell electric vehicle works, what is the architecture of it, what are the key components of it, how does it operate, all these things. And based on that, we'll see what are the currently available fuel cell electric vehicles are there in the market. So if there is this technology exists, so definitely someone has worked on it, and some companies might have launched some models. So what are those models, popular models all over the world? we'll have a look at a few models. After that, why this technology could be considered as a future of mobility. So currently we all are talking about battery electric vehicles, but hydrogen fuel cell also has a great future ahead, and why people and experts think that. So we'll have a look at the reasons behind it, and at the end we will see what are the challenges in adoption of hydrogen fuel cell electric vehicle technology. Okay. And lastly, we'll see what is the scenario going on currently in India about the hydrogen cells and all. So all these things we'll cover in today's session, and I hope you will enjoy the session till the end. Okay, so be attentive till the end and listen carefully. So first thing first, what is the fuel cell? So as the its name defines, we'll break down the name first. So there is a fuel and there is a cell. Okay. So cell we know batteries which provides the electricity. Okay, and fuel, the way we put some kind of fuel in our vehicle, whether it's a gasoline or the diesel, so that's the fuel. So fuel cell means we have to put some sort of fuel in there, and as a result it will give some sort of electricity to us. So that's it, terms itself defines exactly what it means. So what fuel cell is, it's an electrochemical device that generates electricity, okay, as a result of chemical reaction of fuels. So the fuel we have to fed in inside a specific structure of a fuel cell, and once we put the fuel in, it reacts. There is a reaction among the fuels, and which results in a uh, electricity generation. So that's the basic funda of fuel cell. So this is the schematic diagram of fuel cell you can see. So what happens, there is a fuel inlet here, which is most of the times hydrogen, and here the second fuel, which is the air. So from air we need oxygen. So these are the two inlets from where we feed the fuel. And what happens when fuel comes here? It's in contact with anode and the catalyst. So what happens? It disintegrates. So hydrogen fuel, it disintegrates into the proton and electron, and there is an electrolyte and a membrane here. What happens? The positive ions are allowed to pass through it, but electrons, they are not allowed. So what electrons do? Electrons try to find out some other path, and they follow the external path to reach till the cathode side, and proton also reach there via the electrolyte, and here they combine with another fuel, and as a result we generate electricity and a byproduct. Some byproduct is there. So this is the basic schematic of fuel cell. We'll see in detail with the help of animation how does it work. So how exactly it is constructed and what all parts are involved in a fuel cell. So in a specific battery, we say we have a positive tab and negative tab. Then there is a cathode, anode, electrolyte. So this is one type of storage device, is a electric battery, lithium-ion battery, nickel-cadmium battery, any battery. But this is the another kind of energy storage device, fuel cell. So what are the different parts of it? So there are electrodes basically, as in battery. So anode is there and cathode is there, and what happens? These anode and cathode they react with the fuels, and they allow the separation of these fuels and combination of them. So these are the roles of anode and cathode. Then there is the electrolyte, which allows only protons and specific nature of material to pass through it. So that's it. And after that there is a catalyst for a quick reaction. So we want electricity generated to be generated very quickly, and it should not, the reaction shouldn't take a much time to generate electricity, so it won't fulfill the exact requirement. So what we do, we add in catalyst. So majorly the catalyst most of the time is a noble metal, which is platinum. So that's the catalyst. And after that there is a gas diffusion layer. So gas diffusion layer helps to diffuse the gas, like distribute the gas all over the cathode and anode in an equal manner. And surely there are inlet fuels, so we have to give some ports to enter the fuel, and some ports to exhaust, to get out those excessive fuels. Okay, and definitely we have to have some external circuit which will allow electrons which are generated as a result of chemical reaction between the anode and cathode. So this is the exact structure of the fuel cell, and these are the key elements of it, how exactly the fuel cell is constructed. So I hope you guys understood this part. So moving ahead, how exactly a fuel cell looks like. So this is one of the fuel cell. You can see it's completely different from the batteries. So here the small, I will just zoom in so that you can see it in a detail. Okay, so you can see here are some plates and extruded part are there a little bit. So what are these? These are anode and cathode, and we pass hydrogen from a very controlled manner, so that and from another end we pass the air. So what happens? These hydrogen and air react. So from here you can see the hydrogen output. So what we do, from one way we enter the hydrogen, and excessive hydrogen gets emitted from here, and water is added, the air is added from the another end, not water, just air, at a specific pressure. So pressure has to be maintained, and the control has to be there when we allow these gases to be passed through, and they go within these stacks. There are so many cells. You can see there are hundred of fuel cell stacks here. So they generate electricity, which is extracted from the another end via electrical connections, and excessive fuels are also allowed to pass through it. So this is how the exactly one fuel cell stack looks like. Hope you got an idea, and if you might have not seen it prior to this, so you would get a little bit idea how exactly it looks like. Okay, so moving ahead, what are different types of fuel cells are there? So this the hydrogen fuel cell is just one of them, but there are multiple fuel cells that scientists and chemical engineers, researchers have come across, developed. So there are like solid oxide fuel cells, then molten carbonate fuel cell, phosphoric acid fuel cell, alkaline polymer electrolyte fuel cell, then direct methanol fuel cell, and each of them has their different properties, different operating temperature, different input fuels, and different output voltages and current characteristics. So depending on what are what exactly they give as an outcome and what conditions they operate, we can use them for that specific suitable application. So seeing this chart here, you can see whatever the fuel types of fuel cells are listed, their operating temperature, what fuels they use, and what electrolyte they use, what as a electrolyte material, what material they use. So these things are listed, and based on these, what we will do, we'll short activity will do, we'll find out which one of them is best suitable for application in electric vehicle. So fuel cell, you see that it generates electricity, and that's what we require to run our electric vehicle. Currently we are searching for alternative to our gasoline, diesel, CNG vehicles which emits harmful gases, and we are finding electricity a good source of running the vehicle. And in search of that, we are looking for different sort of sources that can generate electricity, and fuel cell is one of them. So there are multiple fuel cells now we have come across. So out of those fuel cells, which one would be best suitable for electric vehicle application? So that thing we have to see. So you can see there are around, yeah, 6 fuel cells are listed here. Their operating temperature is given, which fuel they use, and what electrolyte material they have. So can you guys let me know on the basis of these parameters going through it? You can take just 1 minute of time, and based on what data is available here, you can just comment on it, which cell, which chemistry of the fuel cell would be best choice for as application in electric vehicle. Okay, so yeah, I will encourage you to take part in this activity, quick activity, and let me know which among these fuel cell would be a best suitable for our electric vehicle related application.
I think it would be solid oxide. because the temperature is very low, 40 degrees Celsius to 90, right? The
No,
machine
no,
will
they
get lower heat.
this don't see this text, just see this image which is here. So what you are saying about is this polymer electrolyte membrane fuel cell.
Okay, then it would be PEMFs.
Which one you are talking?
First one,
First one.
PEMF. Yeah.
Yeah, exactly. Okay. Anyone else would like to follow Shailesh?
First and third one.
First one and third one. Okay, direct methanol fuel cell. Okay, all right, all right. So we'll see which one exactly could be used specifically. So this is a polymer electrolyte membrane fuel cell, and you can see its operating temperature. So each fuel cell has a different operating temperature. So for solid oxide fuel cells, we have to maintain the temperature between 600 to 950 degrees Celsius, which is completely impossible to be maintained in a vehicle. So we'll surely avoid the fuel cells which require high temperature to be operated. So all these three will surely be eliminated from here, and these top three we can think of. So DMFC, direct methanol fuel cell, it also has to be run at a elevated temperature, which is 60 degrees Celsius, which is quite above our uh, environmental condition, and around which we have to have a specific thermal management system to maintain this range of temperature. But 40 degrees Celsius seems somewhat achievable. In India, we can say a 40 degree is a normal temperature in most of the regions during the summer time. So it won't be a problem running these cells on a normal environmental condition during summertime. But when it's like a 20 degree or somewhere around that, so we have to elevate the temperature a little bit. But the 40 degree seems less difficult to achieve when it comes to operate the fuel cell. So among these two we can use, but polymer electrolyte membrane fuel cell is most preferred to be used in electric vehicle application, because it has a hydrogen as an input, and there is a polymer electrolyte, so it does not require potassium hydroxide to be used, and there are like more other benefits of using this. And this particular cell, fuel cell, polymer electrolyte membrane, is itself called as a hydrogel fuel cell. So this is the what this is exactly the fuel cell which the people who manufacture, the companies who manufactured the fuel cell electric vehicle have used in that particular vehicles, as well as what other companies are researching on. They are also doing taking this chemistry forward to be for the electric vehicle application. So okay, so now we'll see how exactly the this polymer electrolyte membrane, or the hydrogen fuel cell, another name of it we call it as, how exactly it works. So
Excuse me, sir, I just had a doubt.
yeah, Mohammed Iqbal.
So, are we saying that we cannot run this fuel cell in Jammu and Kashmir?
What we have to do is we have to maintain that elevated temperature. So what we have to enclose it in some structure where we have to uh, maintain the temperature between that range. Okay, so these are the things. So it is the same case in terms of battery electric vehicles as well. If there is a temperature below 20 degree, 10 degree, 20 degree, so their performance also get affected. So these kind of things are there with these fuel cells. But if we are able to develop systems which maintain the range of this temperature to be operated at, so we can surely use them in Jammu and Kashmir as well.
I had one more doubt. So, as I
Yeah.
earlier said, it is 40 to 90 degrees Celsius can be used in vehicles. But
Mhm.
what the thing is this temperature is enough to use the fuel cells in an effective manner? Is this temperature is enough to
Yeah.
keep in a vehicle?
Our engine itself generates a high amount of heat, and we have a dedicated cooling system for that, right? To
Correct, correct.
maintain its elevated temperature, because the engine also does not give a best performance when it's in a cold condition. So we arrange, like we provide those thermal systems in engine. So in a similar fashion, we can also provide these temperatures to the fuel cell.
Okay.
Okay, okay, all right, all right. So we'll move ahead and see how exactly this hydrogen fuel cell works. So I guess this animation pretty much explains the working of this cell. So what happens, this is the schematic of one fuel cell stack, and as we have already seen in that physical actual fuel cell, there are hundreds of such stack. So how what one fuel cell stack works is we allow the hydrogen gas to pass through the anode side, and it comes in a contact with the gas diffusion layer, which distributes it equally all over the anode part, and it comes in a contact with catalyst. So catalyst in hydrogen fuel cell mostly is a platinum, which allows the separation of proton and electron. So you can see it gets separated in a proton and electron, and protons, they are allowed to pass through the this membrane, which is a proton exchange membrane, and it reaches to the cathode side. And at cathode side, we have a inlet of air where there is oxygen, and that oxygen, this proton and the electron, which find the external path to flow, and that's the exactly how we get electricity. So electron, it passes through the external path. All three of them come here, and the reaction happens that results in a generation of heat, and the product of that reaction is when hydrogen oxygen reacts, it will surely give the water as a byproduct. So this is how the one fuel cell stack works. Okay, so I guess I didn't give you the recompense. Okay, so this is how it works, and at the cathode end, all the electrons, proton, and oxygen, they combine, and they result in a water and a heat. So this is the working of one hydrogen fuel cell, and what we do, we, like in a lead acid battery, we have a 6 lead acid battery connected. So in a similar way, we connect multiple hundreds of fuel cell stacks in a one entire fuel cell, and that's how we get the uh, expected result output. So in what one fuel cell generates is less than 1 volt of output, so which is very less. So that's the reason we have to put a lot of stacks in a one entire fuel cell. And if we compare it with our regular lead acid battery, which is used in current automotive industry, so those one cell gives around 2 volts, and that's why we put 6 cells in series to get the 12 volts as output. But here it gives less than 1 volt, just one stack, which is a very small in size as compared to lead acid cell. That's why we put hundreds of cells to achieve the expected voltage outcome. Okay. Yeah. So now we'll talk about why hydrogen fuel cell are like suitable for the electric vehicle application. So here is a chart in front of you. Can you guys do you guys know what this particular chart is called, and what things it specifies? Like these what are the terms listed here? What is the common among all these things? So actually this is a very important chart when we are trying to select a specific source to be put in some application. Okay, just I don't think some of you know the name of this particular chart, but just try to answer that. What is common among all these terms listed in the chart?
It is showing some energy level. So how can a machine can work while we are using a capacitor, when we are using an ultra
Mm,
capacitor.
mm,
So when we are using this Leon batteries, lead acid
mm,
batteries.
So
It is
what
showing the
all are these devices
energy.
basically? These are actually energy storage devices, and this
Yes.
chart compares the different types of energy storage devices on the basis of how much the specific energy they store and how much power they deliver. So what this chart is called is a Aragon plot, and it's used to, as I mentioned, to compare the performance of different types of storage energy storage devices which are there. So on vertical axis, what you will find is how much energy stored in per kg of the storage, and on the horizontal axis, you will find how quickly this energy can we can extract. Okay, so uh, what what will be the best zone in this particular chart that we would expect from ideal energy storage device is it should store a huge amount of energy, as well as it should uh, we should be able to extract or get that energy quickly whenever required uh, in that particular instant. So considering the extreme positions here, so whichever device is coming in this region, this corner would be most suitable for the application. Okay, so we'll try to find out how the fuel cell could be a reason to be the choice of energy storage device for electric vehicle. So we can see it comes at the very top of the vertical axis, and that defines that it has a very high capacity of energy storage. So within a small volume, it stores the large energy, and but on the horizontal axis, if we see, it does not deliver the energy very quickly, basically. Okay, so the energy delivery, I'm sorry, it's written high, but it's low, basically. So capacitors, if we talk about uh, capacity, so what they do, they store a little amount of energy, but they are able to give that energy very quickly, right? They discharge very quickly, so they are used in that electrical circuits and all. So capacitor, they discharge energy very quickly, but fuel cells, they are not you cannot extract the energy from fuel cells. We have to, like, their output is low, so we have to have certain external electronic circuit to maintain the output from this fuel cell. So being a high level of energy storage device, we can use it for electric vehicle application. So yeah, so now we have seen that the reasons to be using hydrogen fuel cell in electric vehicle. So we'll now see how does the fuel cell electric vehicles work and what is the architecture of it. Okay, so here is a diagram that represents the flow of different energies. So the green one that you see, it shows the flow of hydrogen. Okay, and the blue one, whichever is there, so it shows the flow of electricity. And wherever there is a red arrows and red marks, so it shows the uh, can uh, can you please unmute yourself? Okay, yes. So wherever there is a red marks and arrows, it shows the flow of mechanical energy. Okay. So what happens in a fuel cell electric vehicle? We have to fill the fuel tank, which is a hydrogen fuel tank. So there is an inlet, and we fill the hydrogen in the tank, and that tank stores the hydrogen. And whenever we turn on the vehicle, that is fed to the fuel cell stack, and that is fuel cell generates the electricity. So this electricity can be used directly to run the electric motor, traction motor, and also if there is excessive amount of energy which is being generated, so we can use it to charge the battery pack. Okay, so there also we require a battery pack, because we cannot be completely dependent on the fuel cell. As we see, we it does not give the desired power output or power output as quickly as possible. So that's the reason we have to have some battery, but not as large as we have in electric vehicle. It will be of very small size, and for a specific duration of time it will be used, but it also charges the battery. And in some conditions, if we require a high power, like when you are driving a vehicle at a high speed, so at that time you need a more power. But at that instant, fuel cell alone is not sufficient to give that much of power. So at that time, this also will be used, and the energy which is stored in the battery pack will also be used at the same time, so that we get a good power at the motor, and it can propel the vehicle faster, which is the drivers or driving conditions requirement. So that's how the general and a basic structure of fuel cell, general architecture of fuel cell electric vehicle works. And there are different modes of operation we can have. So one mode could be battery only. When there is a lack of fuel in a tank, so we can just whatever battery is charged. So on that mode we can run. And second one is hydrogen only. So when we are not using much energy, and like whenever we are running a slow condition in a city urban areas and all, so we can just use the fuel cell and cut off the battery power. So that's the another mode. And a third mode is a combination of both, so that we discussed earlier, that when we are cruising and running the vehicle at a high speed and it's climbing on a hill or something, that at that stage it requires a good amount of power. So we have to uh, turn on both the battery and the fuel cell power to be delivered at motor. So that's the third mode. And fourth mode could be regeneration mode. So it does regeneration. What we'll do when we are going down the hill or braking at some stunt. So the motor will act as a generator, and whatever energy is generated the help of rotation of wheels, it will get stored in the battery pack, which again can be used. So these are the different modes on which fuel cell electric vehicle can be operated. Okay, so before moving ahead, if you have some doubts on this, let me know, or we'll quickly jump to the another topic. Okay, okay. So yeah, we'll move ahead and see what are the
Sir,
currently.
how electric motor and engine is connected?
There is no engine in fuel cell electric vehicle. It's completely battery and fuel cell operated, and there is a
Sorry, sir. Hydrogen fuel cell and a battery. Hydrogen fuel cell and battery.
so, hydrogen fuel cell, it has a output ports which from where you can connect the motor, but they are not surely connected directly. There is some power electronics and converter devices and motor controller are there. So we connect in that manner, and very controlled manner electricity is passed through the motor, whichever is required at that particular instant. So these are the things. There are like completely electrical connections, cables and wires, but some sort of power electronic devices are there to control that. All right. So we'll move ahead and see what are the currently available fuel cell electric vehicles. So today, all of us are talking about battery electric vehicles and hybrid electric vehicles, but there are some models, some companies have developed fuel cell electric vehicles. So does anyone of you know what are the currently available models which runs
Sir,
on a hydrogen fuel cell?
Toyota Prius.
Toyota Prius. No, I guess Prius is not a hybrid vehicle. Is if it's a hybrid electric vehicle and not the fuel cell electric vehicle.
Oh yeah, Mirai. Yeah. Sorry.
Yes, Ayush, the Mirai, Toyota Mirai is the we can say a first mass-produced hydrogen electric fuel cell vehicle. Cool. And any other name you guys know in a race of fuel cell electric vehicle? Mirai is quite popular. Yeah, sure. So as the Tesla is a poster boy of electric vehicles, so in a same manner, Mirai we can say is there. Okay, Manu has told Chevrolet Colorado. Okay, Colorado. No, Avenia is not a fuel cell of it's a concept electric vehicle, battery electric vehicle from Tata that they recently showed. Okay, okay. So we'll move ahead and see what are the different models available. Okay. So here are the three popular fuel cell electric vehicles that automotive manufacturers had developed. And as Ayush said, there is a Toyota Mirai. So it was launched in 2014 by Toyota, and it's the first mass-produced fuel cell electric vehicle, which gives the range of 647 kilometers that Toyota claims. So you can see in 2014 they launched fuel cell vehicles, which has a more than 600 kilometers of range, and in 2022 we have highest range in India that any vehicle gives is a ZS EV, which is around 500 kilometers or something. But Toyota, with the help of fuel cell electric vehicles, they did it in 2014 itself. And their new model, like facelift and upgraded model, has also been launched recently. So that thing you can also see how amazing it is. At that time, they developed the 600 kilometers of range, and after that, there is a Hyundai Nexon as well as Hyundai Nexo, basically not Nexon, it's Nexo, and Honda Clarity. So these vehicle also completely runs on the fuel cell. Hydrogen fuel cell only. They have a fuel cell, hydrogen fuel cell tank and all, and there are many buses and trucks also developed by many companies for the research and development purpose, and not for the specific public transport. But in some countries, they have been using it as they develop, so they have been using these buses and trucks. So there are these models practically implemented and like available in a passenger vehicle segment, and hope we'll see more of it in India in future. So we'll see why the hydrogen fuel cell electric vehicle can be considered as a future of mobility. So we all have been talking like electric vehicles are the future of mobility, battery electric vehicles, but they are not the future. They have now become the present, and people are adopting the electric vehicles. People are buying them and using them. So what exactly could be the future of it? We have been using battery electric vehicles. We have started using battery electric vehicles now, but there are a few advantages of hydrogen fuel cell electric vehicles over these battery electric vehicles. So we'll see one of them. So there's a one major advantage that we have is availability of hydrogen. So in battery electric vehicle, what we have is a lithium batteries, which are most popular. So the extraction of lithium is very much we can say a difficult process, and it's not like equally available in all the countries all over the world. So what we have to do is we have to be dependent on the countries which have the resources of lithium. But when we talk the availability of hydrogen, it's a most abundant element all over the earth. We can get it from water whenever we require. So that's the one key reason of seeing fuel cell electric vehicles as a future. And what we are looking for is a zero emission solution, which it surely provides. Then we have seen they give the longer range than battery electric vehicles. So you saw in 2014 that Toyota was able to achieve more than 600 kilometers of range, and till in 2022 itself we are not having a good range battery electric vehicle. So they give the higher longer range, as well as they are lighter as compared to battery electric vehicles. So battery electric vehicles, most of the weight is occupied, like around one third to half of the weight of entire vehicle is because of the batteries which are put in there. But fuel cell, as we saw in a Aragon's plot, that it stores high energy within the less weight. So it gives the lightweightedness to the vehicle, which can be used to have a better range out of that. And the very key element of seeing this as a future is a fast refueling. So we have certainly developed a fast charging stations and fast charging technologies, but those also required almost hour to get the 0 to 80% charged. But hydrogen fuel cell, it can be quickly filled within 10 10 minutes itself at the fuel diffuser. So you can see how quickly we can get the long range as well as lightweightedness as well as the quick refueling. And their life cycle is also very much higher than the lithium ion cells. So lithium ion cells, they get like they die and they get disintegrated within 3 to 4 years. So they don't have a quite long life. But hydrogen fuel cell can be used for 8 to 10 years, that kind of thing, if you maintain them properly. So this is the key. These are the key reasons that we can consider fuel cell electric vehicles as a future of mobility. And we'll surely look at what all are the challenges of adopting this technology. Okay. So before that, I would like to ask one questions to you. If we all are aware of the advantages of fuel cell electric vehicles, um and we know that battery electric vehicles are not in a competition of fuel cell electric vehicles. So why still manufacturers are going for battery electric vehicles and not they are trying to manufacture the fuel cell electric vehicles? Just few of them are doing it. So what could be the possible reason from your perspective?
Storage of hydrogen.
Yeah, Tirath, that's the one big challenge in getting the fuel cell electric vehicles, because hydrogen, the storage of it, like it, as we saw, it stores a lot of energy, so it has to be stored very safely. So yeah, that's the one key reason. Yes. What could be another reasons?
Refueling stations.
The refueling station, or we can say uh, the infrastructure of the diffusers in the country.
Maybe extracting of hydrogen is a quite difficult process.
Okay, but we will see how the hydrogens are extracted in upcoming slides. Okay, all right. So I guess we don't have much time to be discussing. Yeah, I really appreciate people who answered and unmute themselves. So we'll move ahead and see what are the challenges. So whenever there is a technology evolving and getting introduced to the public, so there surely are challenges in adoption of that. And the first challenge is the extraction of hydrogen. Okay, so hydrogen can be extracted from two different ways. One is from hydrocarbons. So we have a list of alkanes, alkynes, which has a carbon and hydrogen. But from if we go with that method, we will eliminate the carbon. We will get the hydrogen surely from there, but we'll eliminate the carbon, and that's what we are trying to reduce. And if we are ending up eliminating the carbon, then it doesn't make sense extracting the hydrogen with that method. So we completely try to avoid it from getting hydrocarbons. And what we do is we get it from water. And from water, how we can separate the hydrogen is a method called electrolysis. So we have studied in our lower standards that electrolysis is a process. We pass the electricity through water, and we get the hydrogen and water separated. And you can see this is the completely opposite of what fuel cell exactly does. We combine hydrogen and oxygen and generate electricity. And what electrolysis does is it we pass the electricity through water, and it separates the hydrogen and oxygen. So this is the process, electrolysis process we use to extract the hydrogen. But the way we use the way we produce the electricity to do this process, on the basis of that we have different types of hydrogens. Okay, so there is a brown hydrogen. Why it is called brown hydrogen? So when we generate the electricity by using the coal, and that electricity is used for electrolysis process to produce hydrogen, then it will be called as a brown hydrogen, which is definitely not advisable, because producing the electricity from coal, it affects the environment in a very bad way. So this is not something we cannot go with. And then there is a gray hydrogen. So why it is called gray hydrogen? We use natural gases to produce the electricity, and that electricity used to perform the electrolysis to get hydrogen. And if we use this method, it's called the gray hydrogen. And there is another thing called a blue hydrogen. So we also use the natural gases here, but whatever carbon we emit, we capture it, and we use it for some other purpose. So that's called the blue hydrogen. But when the water is produced by the electrolysis, sorry, the hydrogen is produced by electrolysis process, and that electricity is generated from the renewable source of energy, then it will be called as a green hydrogen, because there is no harmful emission involved while producing this hydrogen. And that's the thing we are looking for, to not harm the environment in any way, that we are generating the source of energy. So if we are getting the hydrogen which is being generated with the electrolysis process, and electrolysis process, the electricity is generated from the renewable resources like wind turbine and solar electric power and all such that. So then only that will be called as a green hydrogen. And if you are using green hydrogen, then only we can say using the fuel cell electric vehicles makes sense. Otherwise, if we use the blue hydrogen, gray hydrogen, and brown hydrogen, so if we are not polluting the polluting the environment by our vehicle, but we are polluting it by a source of energy that we are producing. So that's a completely contradictory part. So that's why green hydrogen should be promoted to be used in fuel cell electric vehicles. And there are other challenges as well. So there is a hydrogen transportation, and so like transportation, we have to store it in a very specific process is there to store it, and it contains more than 3 times energy than gasoline. Okay, so we saw in the Reagan plot, having stored this lot of energy, we have to be very sure with the system that we have developed to store this. So that's the very we can say very crucial engineering is required, and a very thorough uh, research and development has to be done to produce its storage as well as the transportation system. And fuel cell infrastructure. Uh, but now we are shifting towards electric vehicle, and we are struggling with setting up the charging infrastructure, right? In major most of the cities, we still don't have a facility to charge a vehicle at public places and all. So we are struggling in making the charging infrastructure. Yes, there are companies who are doing great, and there are a lot of government initiatives and subsidies taken for setting up the charging infrastructure. But this is the challenge we are facing to adopt electric vehicles, and same challenge we will face when we shift to fuel cell electric vehicles, setting up the lines to distribute these hydrogen all over these outlets and all. So this will be one of the key challenge. And hydrogen tank, we have to, as we saw, that we can store a lot of energy. So to put that much energy and to have it contained safely throughout the operation, so as I mentioned, it requires a huge crucial engineering there to develop such kind of storage tanks. And Toyota has been researching on this thing like for a quite long time, and that's how they developed their Toyota Mirai as a practical application of it. And lastly, there comes the total cost of ownership. So whenever any end product is there that consumer uses, so we calculate the total cost of ownership of it. And how it is affected is we see the generation of renewable source of energy, then from that performing the electrolysis and getting the hydrogen and storing it and supplying it, and completely maintaining the pressures and its storage temperature and all. It takes a lot of we can say money to produce all this system, and that's how the cost for the end consumer will get affected. So it is costly. So if I talk about the cost of Toyota Mirai, it's somewhere around 40 $50,000 in terms of dollars, and if you convert it to Indian rupees, it's somewhere around 40 lakhs. So it's something that middle class people cannot afford. So those things are the challenges in adoption of hydrogen fuel cell technology. All right. So coming to the some thing that we should be concerned about, how things are going on in India about the hydrogen technology. So you will be glad to know that our government has launched the National Hydrogen Energy Mission, and they have like allotted a budget of 800 crore rupees to be like invested in a hydrogen extraction technologies and all. And what is going on in India is Reliance has taken initiative to develop a plant of which is like a 5,000 acre of area. They will generate hydrogen there to be used for this fuel cell purpose. And there's a our government gas authority of India Limited, they have set up 10 megawatts of hydrogen generation plant in Madhya Pradesh, as well as there is an Indian Oil Corporation. They are also working towards development of green hydrogen in Mathura. And lastly, our favorite Tata Motors, they have they were given a task to develop a fuel cell electric vehicles by our uh, road and transportation highway ministry. So they developed few of the fuel cell electric vehicles, and they are being run on the Delhi and Gujarat states. So this kind of activities are going on in India when we talk about hydrogen fuel cell, and our government has a great vision of taking it forward and being leading in this technology of hydrogen fuel cell, because these technologies we can for hydrogen we don't have to be dependent on other countries, as in terms of lithium we have to get it from other countries which have the resources of that. So whichever resources we have, we should try to utilize it and get the best out of it, and that's what our government is trying to do. And our Ministry of Highway and Road and Transportation. So they are also very visionary about this, and making the India a leading country in hydrogen technology. So this is the thing currently going on in India, and you might also go through and do the research about hydrogen technology, how it works, and what are the things like uh, to be done yet not been prepared, and requires to be a future proof this technology. So yeah, now I guess I would like to conclude today's session by revising what all things we saw in this 1 hour of session. So firstly, we talked about what are the fuel cell and its different types of it, and how does exactly it works, flow of hydrogen and all, and how the electricity is produced. Then how does the fuel cell electric vehicle works? What is the architecture of it? And after that, we saw what are the different models that are developed on this technology that uses a hydrogen fuel cell, and which are like Toyota Mirai, Hyundai Nexo, and Honda Clarity, like that. And why it could be considered as a future of mobility, and why it should be adopted, and then what are the challenges there that we might face when we will try to shift to this technology. And in the end, we saw what are the things required in, like what are the things currently going on in India, and what visions our Indian government has about this hydrogen technology. Okay. So if you guys have any doubt till what we discussed and whatever things we covered in today's session, please let me know. I am here for 2-3 minutes, and after that, I have a little surprise for you guys. So just be little interactive for 2 minutes, and after that, I will show you what is.
Hello, sir.
Yeah, yeah. Abhish.
Currently, which type of hydrogen is being used in fuel cells? Either gray hydrogen or green hydrogen?
It depends which country you are using in and from which outlet. So in like it is not very common having a fuel cell electric vehicles. They are majorly used in US, and not in entire US, some specific west coast region of US only. There are just few outlets of it. So we'll have to see how exactly those outlets are getting hydrogen generated at their end. But uh, it is completely like it should be green hydrogen only, because if you are getting hydrogen from any other way, it doesn't make sense making use of that hydrogen to be called as a green energy in a vehicle.
Oh, okay, sir.
Okay, so I will ask one little question that what do you think, which technology is better, the battery electric vehicles or the fuel cell electric vehicles in your vision?
Combination of both.
Yeah, sure. In fuel cell electric vehicles, there are batteries, but and if you are using combination of both, it will call as a fuel cell electric vehicle only then. But having a complete battery electric vehicle or having a fuel cell vehicle, I am talking about.
Fuel cell vehicle is better, but there it needs some more improvement.
Definitely. So if I like compare the not from the manufacturing point of view, but after use scenario. So what happens? We are using a huge amount of batteries in a vehicle, and now we all are trying to get the electric vehicles on road and promoting it. But what will happen in a few after a few time? We have not yet developed a good technology to recycle those batteries. Okay, and we what why the key reason we are shifting towards electric mobility is to reduce the pollution, and another reason is that our resources of gasoline and all the natural gases are being depleted. Okay, so they are limited. But have you thought that lithium is also limited? It's not available in an infinite amount. Whatever we are putting in a battery, it also might get like completely vanished. Its resources might get vanished. So that's also the thing we have to see when we are talking about electric vehicles. Okay, and another thing is, as I was saying, the first thing, the recycle of battery. It's a huge challenge. The total amount of the batteries which are being used globally, whether it's a for electric vehicle application or for any electronic appliances, mobile devices and all, we are not recycling this. Out of 100%, only 5% of batteries are like recycled globally. So you see 98% of they are being like uh, dumped in a uh, like land filling, and they're going in a land filling, and that's harming the soil. So soil is also a good thing that we are dependent on. If we are polluting the earth and soil, so what is the reason, like what is the meaning of using that technology and calling it a green technology? So these are the few things we have to see when we are talking about the adoption of battery electric vehicles. And one more thing, if I talk about in a comparison of hydrogen fuel cell, so refueling the hydrogen is it doesn't take a much time, but charging the electric vehicle, it takes a lot of time. Whether it's a fast charge, it will take surely 1 hour at least to get the vehicle charged. And we already have we are like millennials and generation X people. We already are suffering from the anxiety of losing the batteries. We charge our phones, we charge our Bluetooth devices, we charge our laptops, and any appliance we use, we have a certain sort of anxiety that it might get discharged. And we surely don't want to add one major thing to it, that I have to charge my vehicle and that kind of thing. So the fuel cell electric vehicles solves this problem. It can be charged quickly at the outlet, but definitely there are challenges in setting up this kind of long, we can say a huge setup of infrastructure for diffusers and all. All right, so I guess you got my point, and I appreciate you guys listening to attending this session. And as I told, I have something for you. So there is one link I am posting in a chat box. If you go through that link, uh, it's a some feedback form, and there are a few topics listed there. Okay, what you have to do, you have to select one of the
Hello?
topic that you are interested in learning about, and our counselor will help you out to get the access uh, for
Hello?
completely free to learn that course. Yes,
Yeah. Sir, can you share your experience, that is research work in fuel cell electric vehicle?
Mr. Mulai, I don't have a practical experience of working with the fuel cell electric vehicles, but I just gone through the what exactly the technology means, and I've gone through the various articles and research papers in this domain. And as a conclusion of that, I have presented my information. As of such, I haven't worked practically with this technology yet. But whatever I got to know, I shared with the students. I guess the mostly of them are from engineering and second, third year or final year of engineering students, who are not like aware about this technology. So my intention was to making them aware about this thing and how exactly it could be there. All right. So yeah, I have put the form link in the chat box. You can go through that form, fill in the details, and choose one specific domain of your interest that you would like to learn about, and you will get the free access to the course. And the 25% of you who will complete that free course earlier will get the certificate to learn that thing. So hope you will fill out the form and learn about the things that you are interested in.
Sir, how are we supposed to get the access of those courses? Because I think I even got an email that which says that congratulations and everything.
You don't
But
get
what
the
is the exact
credentials.
login?
Okay, yeah, login credentials you didn't get.
Okay, and where and that will be through email or
Yeah, the major communication will be via email only. So what I will do, Mohammed Iqbal, is if you, I will just let know my operations team about the thing, and they will find out and try to solve your query.
all right, sure, okay.
Sir,
And
details
sir,
of the
regarding
courses are not mentioned in the Google form link. The duration of the course and etc.
Okay, so give me a second.
If possible, send me the email to me. So I will just forward it to my students also.
Okay, okay, Samad sir. So
Okay. Thank you, sir.
all right.
Very nice session, sir. Thank you very
Okay.
much.
Yes,
Okay.
Dr. Samad. So I actually was trying to see you in the beginning,
Yeah.
but
Yeah.
I guess you might be busy. So yeah, I really appreciate AD Patel College of
Yes. Thank you.
Technical Institute and the students. I really thank you for attending this.
Sir,
Yeah,
will you able to share this PPT, sir?
this PPT. So Agatish, you might find the it recorded on YouTube in a few, maybe tomorrow, day after tomorrow. You can go through the ATG's YouTube channel and you might find the recording there.
Okay, sir. Thank you.
Okay. Okay. All right then. Thank you everyone for the attending this session and patiently listening me and being part of this technical discussion. Whoever unmuted themselves and answered the questions, I really appreciate you guys taking part in the discussion, and I hope you will try to explore more of it and be help our Indian government to achieve its mission of hydrogen technology mission. Okay, so yes, thank you very much again, and have a nice day ahead. All right.
thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Welcome, everyone.